Hello, welcome to EPG Pathshala. Today we will be discussing about the module water quality and its management, and the learning objectives are the basic concept of water quality, factors responsible for deteriorating quality of water, the need for water quality management and its steps. Clean, safe and ample supply of water is essential for the survival of living organisms as well as for the proper functioning of all the ecosystems of the earth. Water availability is affected by natural as well as anthropogenic factors. For a country like India that has to support world's 1/6 population, water pollution is a major issue. Sufficient availability of water can improve sanitation, health and make India a better place to reside. Water quality management. According to Central Pollution Control Board of India, water quality is defined as those physical, chemical or biological characteristics of water by which the user evaluates the acceptability of water. Water quality management deals with all the aspects of water quality, including different beneficial uses of water. For managing water quality, both natural and anthropogenic factors should be taken into consideration. Now, the different agencies that work for water quality standards are: number 1, Environmental Protection Agency (EPA). In USA, the federal legislation controlling drinking water quality is the Safe Drinking Water Act, implemented by the EPA. United States EPA has set maximum contaminant levels that are legal threshold limits on the amount of a substance that is allowed in public water systems under SDWA. To set a maximum contaminant level for a contaminant, EPA determines how much of the contaminant may be present with no adverse health effects. It provides guidance for states and tribes to use and to establish water quality standards, and ultimately provides a basis for controlling discharges or releases of pollutants. Second is World Health Organization. WHO has issued guidelines for drinking water quality that deals with guideline values, different contaminants and information regarding handling water supplies in small rural communities. WHO recognizes that very stringent standards cannot be used universally, and so for a range of guideline values for more than 60 parameters have been elaborated. Third one is Bureau of Indian Standards (BIS). In India, permissible and desirable limits of various parameters in drinking water has been set by Bureau of Indian Standards (BIS) for potable water in 1983 with these objectives. First one is to assess the quality of water resources. Second, to check the effectiveness of water treatment and supply by the concerned authorities. Third, different parameters include color, odor, pH, total dissolved solids, hardness, elemental compounds like iron, manganese, sulfate, chloride, etc. The standard categorizes various characteristics as essential or desirable. These parameters apply to drinking water supplied by different authorities, agencies and departments of state government as well as central government wherever applicable in the country. Next is the need for management of water quality. Anthropogenic activities like change in agriculture practices, excessive use of fertilizers, pesticides have added excess nutrient load in water bodies, causing eutrophication, thus affecting water quality. Siltation due to erosion, industrialization, sewage discharge and other domestic activities have affected water quality of lakes, rivers, groundwater as well as coastal waters worldwide. Also, there is an urgent need for addressing fecal pollution, as there is a direct relationship among sanitation, nutrition and health. There is a need for collaboration of various pollution control bodies, water supply and public health agencies, and different scientific agencies to solve the problem of water scarcity and its management. The availability of sufficient water will not only meet the energy needs but will also ensure food security in India. Now, what are the different factors that can affect water quality management? So, the factors can be classified as natural and anthropogenic factors. Natural factor includes weathering of bedrock minerals, atmospheric processes involving evapotranspiration, deposition of dust, silt, salt by wind, natural disasters like floods and drought. Whereas anthropogenic factors include overexploitation, agricultural runoff and change in irrigation practices, domestic and municipal waste, pathogenic pollution, eutrophication, salinity and toxicity. First one is weathering of bedrock minerals. Both physical and chemical weathering affects the composition of natural waters, increase CO2 concentration in water due to natural or man-made activities, enhance water acidity. Chemical weathering can even reduce rock strength, thus affecting erosion rates of rivers. Suspended sediments can reduce water clarity and quality, whereas fine sediments can affect aquatic organisms like clogging fish gills. Second is atmospheric processes involving evapotranspiration. Evapotranspiration can cause loss of considerable amount of water into the atmosphere from the soil surface and water bodies. In arid zones where low humidity prevails, considerable amount of water is lost in evaporation from soil surface. Third is deposition of dust, salt and air pollutants by wind. Dust, salt and other pollutants from the atmosphere may be deposited directly onto the surface of water bodies or by wind. Pollutants like gases and particulates released from different sources like vehicular emission, crop residue burning and industrial emissions releases compounds of nitrogen, sulfur and heavy metals that deposit directly onto the surface of water bodies and contaminate it. Fourth one is natural disasters like floods and drought. Floods and drought may bring about changes in water quality through dilution or concentration of dissolved substances. Now, the different anthropogenic activities are: first one is over exploitation. The major part of flow of water, about 69 to 96% in most of the Indian rivers, occur during monsoon season that results in limited access to fresh water. Other activities like unsustainable use of water for industries, agriculture and domestic use has resulted in shrinking or drying up of both groundwater and surface water bodies. Wells provide 61.6% of water for irrigation, followed by canals with 24.5%. Traditional farming states such as Punjab and Haryana have witnessed rising exploitation of groundwater resources. Second factor is agricultural runoff and change in irrigation practices. To meet the needs of the growing population, use of chemical fertilizers and pesticides have increased manifold in agriculture in the recent years. Major portion of fresh water is used in agriculture in India. Selenium, a heavy metal, is present naturally in soil, but with increased irrigation practices, it accumulates in the soil, leaches to groundwater and causes toxic effects. Third factor is domestic and municipal waste. Sewage pollution accounts for more than 75% of the surface water contamination in India. Municipalities dispose of their treated or partially treated and even untreated wastewater into natural drains joining rivers or lakes. Around 80% of water consumed by a household is let off to the drains of sewers as wastewater. Fourth factor is pathogenic pollution. One of the major water quality threats in India is waterborne diseases. This is mainly due to inadequate supply of water, improper treatment of wastewater, contamination of surface water and groundwater by sewers overflow, leaking septic tanks that results in spread of a number of diseases like diarrhea, cholera, dysentery, typhoid, etc. Fifth factor is geogenic pollution. The geogenic problems are mainly due to mixing of a large amount of contaminants like fluoride, arsenic, etc. in water. Arsenic is found in groundwater most commonly as the reduced species arsenite and the oxidized species as arsenate. WHO studies indicated that 20% of 25,000 boreholes tested in Bangladesh had arsenic concentrations exceeding 50 microgram per liter. The occurrence of fluoride causes dental fluorosis when fluoride concentration in groundwater exceeds 1.5 milligram per liter. Sixth factor is eutrophication. Globally, one of the most prevalent water quality problems is eutrophication. Eutrophication leads to depletion of oxygen to a large extent, resulting in the death of aquatic organisms and thus unbalanced aquatic ecosystem. Lakes and reservoirs are particularly more susceptible to the negative impacts of eutrophication as they act as an integrating sink for pollutants. Next factor is salinity. Increased irrigation activities, discharge of industrial waste waters or agricultural return water and sea water intrusion in coastal areas has led to enhanced groundwater salinity that makes the water unfit for drinking and for irrigation. Next factor is toxicity. Discharge of toxic effluents, particularly heavy metals, from industries and agriculture water quality. These toxic substances, including carcinogens, leads to the process of biomagnification and bioaccumulation that causes severe damage to aquatic life. For example, dye, textile and wool industries release cadmium, nickel, cobalt in wastewater. Similarly, iron and steel industries releases nickel, cadmium, lead and iron with high chloride content. Next is the steps for water quality management. Before understanding the different steps of water quality management, we should keep into mind the ecological health of water body. A large number of aquatic ecosystems support rare and threatened species and are ecologically very sensitive systems that require special protection. So it is important that in water quality management, the ecological health of water bodies should be given extreme priority. Now, the different steps for water quality management are setting water quality goal, water quality monitoring, identification of nature and magnitude of pollution, source inventory, water quantity information, selection of technology, financing waste management, maintenance of sewage treatment plants, pollution from industrial sources, pollution from non-point sources, and finally some other important options for water quality management. Now let's learn these steps one by one. First step is setting water quality goal. The first step is to identify water quality goal for a given water body. For this, firstly, uses of water like for fisheries, agricultural, navigation, etc. should be identified. In India, CPCB has developed a concept called designated best use. It states that if a water body is used for more than one purpose, then the use that demands highest quality of water is called its designated best use. According to the best use, a particular water body is designated under different classes that helps the water quality managers to identify the needs of water quality restoration programs in the country. For example, Ganga Action Plan and National River Conservation Plan are outcomes of such exercises. Table 1 shows the use-based classification of surface water in India. It includes different designated best use of water, class of water, and the criteria set on the basis of which it is classified into different classes, like drinking water source without conventional treatment but after disinfection should be classified into the class A. The criteria are total coliform organism should be, the total coliform organisms shall be 50 or less than 50. pH should be between 6.5 and 8.5. Dissolved oxygen should be 6 mg per liter or more, and the BOD should be 2 mg per liter or less than that. Similarly, different classes of water has been classified. Now the second step is water quality monitoring. Water quality monitoring helps to know the existing quality of water of a water body. Water Quality Assessment Authority has notified a protocol for this. The protocol includes objectives. For surface water and groundwater, the objectives are monitoring for establishing baseline water quality, observing continuously changes in water quality, supervision of water for irrigation and other agricultural uses, calculation of changes in different water constituents of interest, and groundwater pollution control and its management. Second step in the protocol is frequency and parameters. That includes for groundwater, firstly, all stations under study should be classified as baseline stations. Then 20 to 25% of stations should be classified as trend or trend cum surveillance stations. Second, for surface water, for every month for consecutive 3 years, samples should be collected that will generate 6 samples per year from perennial rivers and 3 to 4 samples from seasonal rivers. On this basis, stations can be classified either as baseline, trend or flux station. Third is sample collection. For sample collection, there should be some basic information required, like the containers should be properly washed before sampling. For proper mixing and analysis of sample, a small air space should be left in the bottle. The containers should be properly labeled. For surface water, there should be a proper bottle or DO samplers can be used. For reservoir sites, sample should be taken from the outgoing canal. The DO of the collected sample should be fixed immediately using a chemical reagent. For groundwater, open duct wells being used for domestic or irrigation water supply. Tube wells with a hand pump for domestic water supply or irrigation. Fourth step is the analysis and record. Sample recipient register. Each laboratory should have a proper register for sample registration. Work assignment and personal registers. For assignment of work and maintenance of records, the laboratory in charge should maintain a proper register. And last step is the analysis of record and data validation. Records of all the required parameters should be analyzed under the water quality monitoring programs. The third step in water quality management is identification of nature and magnitude of pollution. Water quality in different seasons of different rivers is analyzed and compared with desired water quality parameters as per the goals set in step 1. On the basis of the observed data, polluted water bodies in the country are identified, which help in identifying the gaps and nature and magnitude of pollution that is needed to be controlled. For example, taking BOD as an indicator of organic pollution, an attempt is made to estimate the riverine length under different levels of pollution. If a river has high BOD, that means more than 6 mg per liter, then it will be called as a high polluted river. Similarly, if it has BOD between 3 to 6 mg per liter, it will be called as moderate polluted river. Step 4 is source inventory. Point as well as non-point sources of pollution should be identified to understand the water quality of a water body. For point sources, the number of outfalls and wastewater flowing through each outfall should be identified and measured, and then polluted load joining per unit time for 24 hours or 48 hours or 72 hours should be measured. Step 5th is water quantity information. The flow data for different water bodies, like in case of rivers or streams, is acquired at least from the last 5 years or more from CWC, that is Central Water Commission, concerned state irrigation departments, whereas for lakes and other reservoirs, the data should be collected at least from the last 5 to 10 years. The mass balance should be carried out to estimate the dilution that should be available in last 5 years in different seasons. Step 6 is selection of technology. The selection of technology for wastewater treatment depends upon its characteristics and on the treatment objectives. Effluent wastewater should be treated with the aim of providing it for uses like public outdoor bathing, irrigation and reuse of water. Proper collection, treatment and disposal of wastewater are important for controlling waterborne diseases. Technologies like stabilization ponds, constructed wetlands can improve secondary and tertiary treatment of water. The figure is showing constructed wetland. It consists of an inlet for intake of wastewater flowing through a bed consisting of plants and an outlet for discharging of treated water. Next is alternative simpler technology. Simpler techniques like aerated lagoon, oxidation pond, duckweed ponds can be used for wastewater treatment. The top layer of the soil can be used for the treatment of domestic sewage. This technology is being widely used in countries like USA, Australia, Canada and also in India. Another option is reducing the cost of the material that is used for laying down the sewers. Step 7th is financing waste management. It includes effluent tax and benefit tax. First is effluent tax. Approaches like the polluter pay principle can be applied for the dischargers of pollutant like urban dwellers or industries. It will help in waste reduction, treatment and will also generate source of revenue for financing wastewater treatment investment. Taxes or fees can encourage urban organizations to adopt different water saving technologies like using leftover water after cloth washing, using water saving devices like low volume flush toilets. Benefit tax should be charged from the beneficiaries from waste management like local citizens residing in the area, improvement of public health and for the protection and improvement of environment. Step 8th is maintenance of sewage treatment plants. The operation and maintenance of the sewage treatment plants and pumping station requires money and therefore it is a money intensive work. Untrained staff normally runs the STPs. Also, the operational parameters are not analyzed regularly. The treated effluent can be used for different activities like for irrigation, treated sludge, as a manure, etc. Step 9 is pollution from industrial sources. Control of pollution at sources. Industries should follow the proper procedure for treatment of wastewater effluent before discharging it into a water body. The industries committed under corporate responsibility on environment protection should properly follow the protocol. Advanced and new emerging technologies such as aerobic composting, vermiculture, etc. at secondary treatment step should be adopted for reduction of organic waste. A regular auditing of the industries by state pollution control boards of the respective state should be done to control the pollution. Reuse or recycling of treated industries waste and resource recovery. Segregation of wastewater streams would help in reducing wastewater volume. For example, the quantity of wastewater generated in a continuous fermentation distilleries is 7 liters per liter of alcohol produced as compared to 14 to 15 liters per liter of alcohol produced in batch fermentation process distilleries. Similarly, in a sugar industry, if recycling techniques like recycling, wash and reboiler systems are adopted, then the overall quantity of effluent generated could be reduced from 300 liters to 50 liters per ton of cane crushed. Waste minimization and clean technologies. Certain improvement technologies like change or modification of production process or equipment's use that does not affect the product quality, change in input or raw material that is less toxic or harmful, recycling of the chemical and raw materials, recovery of byproducts and waste can help in waste minimization. The spent wash from the industries can be converted into biofertilizers to be used in agriculture. Zero liquid discharge technology should be adopted that can recover around 95% of liquid waste for reuse. It is also essential to introduce energy audit in all the industries. Step 10 is pollution from non-point sources. The non-point pollution sources include rural and slum population, the lack of sufficient water supply and sanitation facilities in rural areas leads to open field defecation that pollutes the surface as well as groundwater. It leads to a number of waterborne diseases like cholera, diarrhea, malaria, typhoid, etc. Diarrhea alone causes 4% of all deaths worldwide. Heavy metal contamination in drinking water also affects the health of people. Like in Bangladesh, some 35 million people are exposed to elevated levels of arsenic in their drinking water supply. The only strategy to reduce the number of waterborne diseases is to provide safe drinking water and sanitation facilities to people in rural as well as urban areas. Second non-point source is agriculture runoff and drainage water. The residues of agrochemicals such as residues of pesticides and synthetic fertilizers can be easily transported to water bodies by surface runoff. They can even leach out into the groundwater, thereby polluting it. Nitrate concentration has been found to be above the permissible level in many states of India. BHC, carbamate, endosulfan, etc. are most commonly used pesticides in India that are affecting the water quality as they are not easily degradable. Drainage waters from irrigated agricultural lands are increasing soil salinity in India. Next source is deposition of air pollutants. Pollutants from atmosphere like gases and particulates released from different sources can be deposited directly onto the surface water bodies and can filter slowly into groundwater, thereby contaminating it. For this, toxins should be properly monitored in motor vehicle emissions and stricter rules for industrial waste disposal as well as ecologically sound integrated pest management policy should be evolved. And the last step is other significant options for water quality management. The following measures can be considered for solving the problem of water scarcity, like encouraging the traditional practices of water conservation like the revive of bawdis, in water deficient areas, as well as encouragement of integrated watershed management that can provide relief from water shortage to some extent. The government as well as the local residents of the area are required to collaborate together. In March 2017, the Uttarakhand High Government has recognized the rivers Ganges and Yamuna as living entities, which means that anybody found polluting these rivers would be seen as harming a human being. Another option is construction of rainwater harvesting systems or groundwater pit formation. Artificial recharge of water tables can also be done by digging recharge wells that can transfer water from the surface to groundwater in the freshwater aquifers. Another option can be spreading of water to allow the water to remain in contact with soil that ensures the maximum quantity of water to seep underground. This has already been done in different states of the country like in Maharashtra and in Gujarat. Another option is adoption of drip and sprinkler irrigation system. Drip irrigation, where a limited area near plant is irrigated, would be the suitable method for irrigation in water scarce areas. This method is particularly useful in row crops. Similarly, sprinkler system is also suitable for such water scarce areas. Today, a variety of sprinkler systems ranging from simple to complex systems are used worldwide. About 80% of water consumption can be reduced by drip irrigation system. These two figures are showing drip as well as sprinkler irrigation systems. Next option can be selection of crop varieties. Abiotic stress resistant crops like heat and cold tolerant varieties do not require more water for irrigation than the older varieties. They are also disease tolerant that reduces the excess application of pesticides. Overall, these types of crops reduce the economic burden on the farmers. For example, Sahbhagi Dhan have been developed through conventional breeding program and are being disseminated to farmers in drought prone areas. And the last option can be reducing evapotranspiration losses can be reduced by reducing the evaporation from soil surface and transpiration from the plants, particularly in arid and semi-arid areas. This can be prevented by putting watertight mulches on the soil surface, zero or no tillage practices, and by constructing wind breaks. Use of drought tolerant species and practicing of dry farming can also be done. Regular removal or clearing of weeds from the field can reduce competition among the crop plants for nutrients, water and sunlight that can affect the overall production of the crop. Next is the conservation of water in domestic use. Water can be easily conserved at household levels with minor changes in regular activities like closing of taps while not in use, preventing leakage of taps, use of leftover water after cloth washing, and water from water purifiers for cleaning purposes as well as in garden. Use of low volume flush toilets than standard toilets can alone save a lot of water. Fresh water is a precious resource, but due to natural and anthropogenic activities like excess and unsustainable use of water in irrigation, in industries as well as in domestic use has affected this precious resource. No doubt there are current technologies available that can treat the wastewater, but in a country like India that has to support a large number of population, there is an urgent need to check the fecal pollution, as there is a direct link among health, nutrition and sanitation. So there is a need for collaboration of different agencies like government, pollution control bodies as well as public participation to solve the problem of water scarcity and its management. Thank you.